Imagine an artifact so mysterious, so historically charged, that it's spurred over a century of really intense scientific scrutiny. Yet its central enigma, it just persists.
Hmm.
Today, we're taking a deep dive into the scientific efforts to understand the most perplexing feature of the Shroud of Turin, how its mysterious, faint image of a crucified man was actually formed.
It's the core question, really.
We've compiled a stack of articles, research papers, detailed notes, from decades of investigation. And our mission today is to unpack these sources, pull out the most important nuggets of knowledge for you, the listener.
That's right. And, the modern scientific study of the Shroud, it really kicked off in earnest shortly after Secondo-Pia's groundbreaking negative photographic images became public. That was 1898.
Right, those photos were revolutionary, weren't they?
Absolutely pivotal, because his photographs first revealed the Shroud's unusual photonegative properties. Nobody expected that. It was completely revolutionary at the time.
I can imagine.
And that revelation, it just ignited this fervent scientific quest. Almost immediately, people started proposing hypotheses for how the image could have formed. They realized, they were looking at something unlike any known painting or artwork.
And then decades later, we get another huge leap forward with STURP, the Shroud of Turin research project. That sounds like it really changed the game.
Oh, it absolutely did. The publication of the STURP findings, starting in the early 1980s, provided this detailed, universally understood empirical evidence, hard data about the Shroud's physical and chemical properties.
Finally, something concrete for everyone to look at.
Exactly. This pivotal research allowed for a critical, data-driven evaluation of the older hypotheses. Many of those had been proposed without, the benefit of such comprehensive data.
Right.
And crucially, it spurred the development of many new ones, because scientists now had a much clearer picture of what any successful hypothesis had to explain. The checklist got longer, you could say.
So if we're diving deep into these hypotheses today, what's our approach? How are we going to tackle this mountain of ideas?
Well, our approach today is to systematically unpack these diverse hypotheses. They generally fall into, let's say, three main categories.
Okay.
First, those involving a dead body alone through natural processes. Second, those suggesting it's a human artifact, created by an artist. And finally, those proposing more exotic mechanisms like radiation or electric fields.
Got it. Natural, artistic, energetic.
Precisely. We're going to explore the ingenious ideas behind them, the meticulous experiments, some really clever experiments conducted to test them, and we'll critically examine the empirical evidence, the facts, that either support or refute each one, drawing directly from the sources we've gathered.
Sounds like a proper investigation.
It is. It's a fascinating journey into really the scientific process itself, where every failed experiment, every disproven hypothesis, it still brings us closer in a way to understanding this extraordinary artifact. Even the dead ends tell you something.
Okay, let's unpack this then, starting with that first category. The idea that the image could have been formed by a dead body alone, just through natural processes.
Right.
The very first one we're looking at is the contact hypothesis, championed by Paul Vignon. What was the initial thinking here?
Paul Vignon, a French scientist, along with Professor Yves Delage from the Sorbonne. These guys were truly among the very first generation of scholars to intensively study the Shroud right after Secondo-Pia's photographs made such waves in 1898.
So right at the beginning.
Right at the beginning. Vignon's initial book on the Shroud came out in 1902. Very early on, he was really at the forefront trying to apply scientific rigor to this new photographic evidence.
And he even had a rare chance to see the Shroud up close, didn't he? That must have been incredible for a researcher back then.
He did indeed. It was much later, actually, 30 years after his initial work. In 1933, Vignon was part of a select group of scientists granted private access to view the Shroud during an exhibition in Turin. An intimate, unparalleled opportunity for its time. It allowed him to examine the fabric, the image, up close. Something very few people before STURP ever got the chance to do.
But without the modern tools, I guess.
Exactly. The unfortunate part, of course, was that this viewing had to be done without any sophisticated instruments. Modern, high-tech, analytical tools, like the ones STURP used decades later, they were still more than 40 years in the future. So his observations were largely, qualitative, based on what he could see.
Given those limitations, what was Vignon's initial thought? How might the image have formed?
Well, in a 1937 article for Scientific American, Vignon detailed his team's extensive work. Their initial inquiry revolved around whether some natural process involving direct contact with a dead human body could produce the Shroud image.
Makes sense. Like a print.
Kind of. Specifically, they looked at whether a body wet with, say, embalming oils or even liquids from decomposition could be responsible for the coloration on the linen. The idea was simple. Physical contact with fluids might chemically react with the cloth or stain it, leaving an impression.
And what did he conclude? Did that simple contact idea hold up?
Vignon concluded very early on that while the bloodstains on the shroud could possibly be the result of direct contact, from pooling blood or contact with wounds,
Right, that seems plausible.
the body images themselves absolutely could not have been produced by mere contact alone. He was quite clear on that point, even back then. The subtlety, the detail, it just didn't fit simple contact.
He actually put that in writing quite strongly, didn't he? It's amazing he grasped that fundamental problem so early, even without all the later STURP data.
He certainly did. In that same Scientific American article, Vignon explicitly stated, and I think it's worth quoting him here, after analyzing the first photographs of the shroud and making our experiments in the laboratory of the Sorbonne, we concluded that the figures are the direct imprints of a human body.
Okay.
It was obvious at once, he continues, that they were not produced by mere contact. For contact between the pliable cloth and the irregular surface of a human body would have caused considerable distortion, and there was little or no distortion in these figures.
Ah, the lack of distortion. That was the key.
That was his key insight. That lack of distortion, combined with the way the image seemed to perfectly map a three-dimensional form onto a two-dimensional surface. It was truly remarkable he identified this crucial property so early.
So he saw the problem with simple contact right away, but did others keep exploring it? What finally put the nail in the coffin for the contact hypothesis after STURP came along?
Yeah, others did continue to consider and experiment with natural contact mechanisms. They tried more refined versions even after Vignon's early conclusions. But once the STURP research results were published, revealing the incredibly detailed nature and complexity of the shroud image characteristics.
Like what specifically?
Well, particularly its precise three-dimensional information content and that lack of wraparound distortion, even over curved surfaces like the face. Once that data was out, all further efforts to promote a natural contact phenomenon for the body image were essentially abandoned by the mainstream scientific community.
The data just didn't support it.
The scientific consensus emerged that there were simply far too many inconsistencies, too many problems, for a simple contact process to overcome. The depth of detail, the resolution, and especially that striking lack of distortion that STURP quantified. It became an insurmountable hurdle.
A good example of science correcting itself with better data.
Absolutely. It's a great example of the scientific process. New, comprehensive, detailed empirical data can definitively rule out a hypothesis, forcing researchers down new paths. The key insight here is the shroud's image isn't just faint. It has this almost impossible geometric precision, this anatomical fidelity, that simple physical contact just couldn't achieve without significant smudging or distortion.
That makes profound sense. Okay, so if simple physical contact is out, what about something maybe more subtle, like gases coming off the body?
Right.
That brings us to the gas diffusion hypothesis. Vignon proposed this too, didn't he? And later, STURP chemist Ray Rogers refined it.
Yes, Vignon's second attempt, you could say. His initial gas diffusion proposal suggested humid ammoniac vapors as the mechanism. He theorized these vapors would come from the fermentation of urea.
Urea, like in sweat.
Exactly. He noted urea is exceptionally abundant in sweat produced during physical torture and fever, which seemed relevant. His idea was these ammoniac vapors would then react with aloes. He hypothesized aloes were spread on the cloth, maybe as part of a burial ritual, sensitizing it, making it react to the vapors and create the image, an attempt at a natural chemical process.
But as you mentioned earlier, a single STURP finding basically shot this down immediately. What was that finding and why was it so definitive?
The critical finding was the shroud image's extreme superficiality. We know definitively from STURP and later research that the image color is restricted only to the very topmost linen fibers on the surface, sometimes just a few hundred nanometers deep. It's essentially a razor-thin surface stain.
So not penetrating the threads at all.
Barely scratching the surface, really. Vignon's hypothesis, though, involving aloes spread on the cloth and ammoniac vapors permeating it, that inherently implies these substances would soak in, penetrate deeper into the cloth's weave, affecting fibers throughout its thickness.
Right, gases and liquids would soak in.
Exactly. This directly contradicts the ultra-superficial nature of the image observed by STURP. So that one key empirical observation invalidated his original vapor hypothesis pretty much right away. Shows how a single precise piece of data can be a death knell for a theory.
Yet Vignon's vapor idea, even flawed, did inspire others, most notably Ray Rogers, the STURP chemist. How did Rogers try to tweak this to make it work?
Rogers made several really significant refinements. He tried to overcome that superficiality issue and other challenges. He proposed a Maillard chemical reaction.
Maillard, like a browning toast.
Exactly like browning toast, or meat getting color when cooked. It's a common reaction between amino acids and reducing sugars. In his model, this reaction would happen between amines, specifically putrescine and cadaverine.
Okay, those sound unpleasant.
They are. They're volatile compounds, heavier than air, associated with decomposition. He proposed these would rise from a decomposing body and react with a microscopically thin contamination layer on the shroud fibers.
A contamination layer? What did he think that was?
He proposed it was a layer of starch, left over perhaps on a very thin surface layer from the ancient linen manufacturing process, maybe from sizing or finishing the cloth.
Did he test this?
He did. Rogers actually conducted experiments with small linen samples treated this way, and he qualitatively showed that a Maillard reaction could lead to yellow-brown coloring on linen treated with this thin starch layer. So he had some experimental basis for the chemical reaction itself and how it might create color superficially.
That sounds clever. A plausible chemical reaction on a surface layer. But were there problems? Inconsistencies that challenged his version?
Absolutely. Significant ones. First, while Rogers reported his spot tests with iodine indicated some starch fractions on shroud fibers, Heller and Adler, in their landmark chemical investigation paper for STURP, critically could not identify any starch on the shroud fibers themselves at all.
Whoa. So a direct contradiction on a key ingredient.
A major point of contention, yes. The fundamental reactant Rogers hypothesized simply wasn't found by other rigorous tests. The apparent absence of starch on the fibers themselves is a severe blow to the hypothesis.
Okay, so maybe no starch. Even if there was starch, were there other issues with a gas diffusion mechanism?
Precisely. The lack of confirmed starch is a huge hurdle. But even if you could definitively show a starch layer was there, there still seem to be many more fundamental difficulties with any natural decomposition gas diffusion mechanism.
Such as?
Well, judged to be among the biggest inconsistencies with Rogers' hypothesis, and really any gas diffusion idea, are the problems explaining the shroud image's extremely high resolution and its orthographic nature, its vertical mapping property.
Orthographic? What does that mean exactly?
Imagine drawing a map where every point on a body is translated straight up, vertically onto the cloth above it, without any stretching or distortion from the body's curves, like a perfect projection.
Ah, I see, like a shadow projected straight up.
Kind of, but with intensity related to distance. This is exceptionally difficult, maybe impossible to achieve, through gas diffusion alone. Gases tend to spread out, disperse laterally. You'd expect a much fuzzier, less precise, and geometrically distorted image.
Especially over something complex like a face.
Exactly. The precision of the shroud image's anatomical details, even on curved surfaces, and its apparent mapping of body cloth distance directly to image intensity, those are incredibly difficult to replicate through simple gas diffusion. It really highlights the importance of explaining all the characteristics, not just getting a faint yellow color.
That's a great point, and a good segue into our second major category. The idea that the image is a human artifact, the work of an artist. This is where we encounter Walter Macrone and his painting hypothesis, a very well-known and controversial figure in the shroud debate.
Indeed. After the STURP scientists finished their initial work in Turin in 1978, they were allowed to take tiny, sticky tape samples from various areas of the shroud for further study back in their labs.
Like forensic evidence collection?
Pretty much.
Right.
And Ray Rogers, as it happens, sent a number of these tape samples for analysis to Walter Macrone. Macrone was a highly respected microscopist, very well known for his forensic work, authenticating artworks, that sort of thing.
And Macrone's findings stirred things up quite a bit, didn't they? He became a very vocal proponent of the fake theory.
They certainly did, and he absolutely did. Macrone reported finding submicrometer particles of iron oxide, specifically red ochre pigment, on the samples. From that finding, he concluded the iron oxide was evidence pointing directly to temper paint.
And therefore
to the painting of the shroud image by a human artist. His ultimate conclusion, published and widely debated, was stark. The shroud image was simply a medieval painting, nothing more.
Now, he was correct about finding tiny amounts of iron oxide, wasn't he? That part is generally accepted.
Yes, he was correct about finding minute amounts of iron oxide. No one really disputes that.
So where did his interpretation go wrong, according to other researchers? Why wasn't it just accepted as proof of painting?
The interpretation is where the controversy lies. For example, researcher Giulio Fanti suggested it's possible some bloodstains were touched up with red paint in the Middle Ages. Maybe to make them more visible for display? Macron might have seen evidence for that.
So localized touch-ups, not the whole image.
Possibly. That wouldn't mean the entire image was painted, just that some areas might have been enhanced later, which could explain some pigment.
But there's a bigger counter-argument from STURP itself, isn't there, about where this iron oxide was found?
Yes, there is, and it's a very significant one. What Macron may not have known, or perhaps didn't emphasize, was that STURP scientists, Morris and Schwalbe, had found iron oxide distributed over the entire cloth, not just in image areas or bloodstain areas. It was everywhere, even in clear background areas.
Everywhere. Why would that be?
Well, think about how linen is made. The retting process, used to separate flax fibers from the stalk, involves soaking flax in water. From the 1st century through medieval times, pond retting seems common.
Okay.
This process often involves iron-rich water. It can easily lead to deposits of iron oxide being left uniformly on the flax fibers during the manufacturing process itself. It's a natural contaminant from making the linen.
Ah. So finding iron oxide doesn't automatically mean paint. It could just be part of the ancient cloth itself.
Precisely. It could be an incidental byproduct of ancient linen production, a background signal, not the signal of the image formation itself.
What about the actual paint debris Macron claimed to find? Not just iron oxide, but like flakes of paint.
He did report finding actual paint debris on some tapes.
Yeah.
And that initially sounded quite damning for authenticity. However, this too wasn't entirely unexpected by many Shroud scholars and historians.
Why not?
Historically, numerous painted copies of the Shroud were made, especially in the Renaissance. It's well documented that these painted copies were often sanctified by being laid directly on top of the original Shroud, a common practice for relics.
Like transferring holiness.
Something like that. Such contact would inevitably leave some paint debris from the copies onto the original, entirely unrelated to how the original image was formed. It's a classic case of distinguishing contamination from the primary object.
So, despite his strong stance in his book, Macron's painting hypothesis faced these major challenges, and most Shroud researchers today don't accept it.
Indeed. Macron wrote a whole book supporting his hypothesis, and skeptics still quote him regularly. But his was really the last in a long line of painting hypotheses that have all been largely discredited, because they are fundamentally inconsistent with multiple, well-established image characteristics revealed by STURP in later research. The image's complexity, its precise 3D information, its superficiality, its non-directionality, the lack of brush strokes, its pseudo-negative properties, these simply aren't explainable by direct painting alone, especially medieval tempera painting.
So finding bits of iron oxide isn't enough. You have to explain how painting could create all those unique features.
Exactly. It highlights the crucial difference between finding components and proving a method. Finding iron oxide doesn't prove it's a painting if the proposed painting method can't replicate all the image's unique and frankly bizarre features. The key insight is the Shroud image is just too complex, too weird to be explained by conventional medieval painting techniques.
Okay, so if not direct painting, what about other artistic methods? Maybe something more like a transfer or a rubbing.
Right.
Emily Craig and Randall Breese proposed the dusting hypothesis. What did their method involve?
Craig and Breese in their research actually managed to produce one of the best results, visually speaking, for a facial image. Very similar macroscopically to the Shroud face.
How did they do it?
Their method was quite ingenious. It involved using powdered pigments, natural ochres, mineral pigments to essentially paint a positive image, often on paper first. Then they'd transfer that image to linen using a wooden burnishing tool, basically rubbing it off the paper onto the linen.
And then fix it somehow.
Yes, the image was then fixed on the cloth using heat, applied to bond the pigment to the fibers.
So visually compelling, but what were the main limitations compared to the whole Shroud?
Well, their effort, while visually impressive for a face, was quite limited in scope. They only created a facial image. They didn't include any blood stains, nor did they try to replicate the unique properties of the blood exudates from wounds, which are so prominent and distinct on the Shroud.
Right, the blood is a whole separate issue.
A whole separate complex issue. Their work demonstrates the immense challenge of replicating the entire complex image, body, face, blood, everything with all its specific optical and chemical characteristics. The blood behaves very differently from the body image. Their technique just couldn't replicate that full range.
Okay, next up, the Bas-Relief hypothesis, explored by Delfino. What's bas-relief artistically, and how did Delfino apply it here?
Bas-relief, it's French, from Italian basso relievo, meaning low relief. It's a sculpture technique where the sculpted bits remain slightly attached to a solid background. Gives a 3D impression without being fully detached. Think of coins or figures on ancient Greek friezes.
Got it. Low-profile sculpture.
Exactly. Delfino's variation for the shroud involved using a metal sculpture of a human face, cast in this shallow relief. He then heated this metal sculpture up to about 200 degrees Celsius, that's roughly 392 Fahrenheit.
Pretty hot.
Pretty hot. And then he pressed linen cloth onto the hot sculpture. The idea was the heat would scorch the linen lightly at the points of contact, leaving a faint, non-penetrating image, like branding, but very gently.
And did his work face similar limitations to the dusting hypothesis?
Yes, very similar. Like Craig and Bresci, Delfino also limited his effort to just creating a facial image. No attempt to include blood stains or the intricate details of blood flows from wounds, which are such a prominent and complex feature requiring their own explanation. Plus, getting a uniform, subtle scorch with the right intensity variations, matching the delicate shroud image just by pressing cloth onto hot metal. That's incredibly challenging without causing excessive charring or deep penetration, neither of which the shroud shows.
Right, controlling that heat transfer precisely seems near impossible.
Very difficult.
This brings us to a really major effort, Luigi Garlaschelli's combination hypothesis, using a human body and bas-relief with frottage. This sounds like a serious attempt to finally crack the artistic replication nut.
It was indeed a very ambitious and comprehensive effort. In 2008-2009, Luigi Garlaschelli, a chemistry researcher at the University of Pavia in Italy, led a very well-funded team. Their specific goal was to demonstrate how the shroud image could have originated from a medieval artist.
And they were confident.
Very confident. Reuters news service reported in October 2009 that Garlaschelli claimed his results proved definitively that the shroud was a medieval fake. A huge claim.
Wow, okay, so how extensive was his work? Did they try to make a full replica?
Garlaschelli's team effort represents probably the most extensive experimental attempt to date to reproduce a full frontal and dorsal shroud image using artistic methods. They started with rigorous study of all the existing research on the shroud image's nature, carefully considering all the previously proposed natural mechanisms, contact, gas diffusion, and other artistic methods.
And they rejected those.
They rejected the natural hypotheses and other artistic methods as insufficient. They then settled on a frottage technique that's French for rubbing, as the most likely method used to, as they put it, cunningly paint the shroud image, echoing Bishop Darcis's claim from 1389 that it was a cunningly painted fake.
Frottage, like brass rubbing.
Similar principle, yes. Rubbing pigment onto a cloth laid over a textured surface.
And what were their results like? Did they manage to replicate those unique shroud properties like superficiality and 3D info?
The effort produced impressive results, especially visually. They got a pseudo-negative image. It was fuzzy. It resided on the topmost fiber, so it was superficial. It had some three-dimensional properties when analyzed by computer. And crucially, the image did not fluoresce under UV light like a normal scorch would.
That non-fluorescence is important, right? Because the real shroud image doesn't fluoresce either.
Exactly. That was a significant achievement for an artistic method, replicating that lack of fluorescence, which is hard to do with simple scorching or painting. It shows they were really trying to match multiple complex shroud properties, not just make something that looked vaguely similar from a distance.
Okay, walk us through their 5-step process. It sounds incredibly detailed and intricate.
It was. It evolved through a lot of trial and error. Here's the final 5-step process they settled on. First, pigment application for the body. They took prepared linen cloth and molded it over an actual human model, often a live person. For the front and back images below the neck, they rubbed a pigment onto the cloth. This pigment contained acidic compounds, specifically sulfuric acid, mixed with red ochre in a water-based slurry. This frottage, this rubbing, transferred the image directly from the model to the cloth.
Acid and pigment rubbed on. Okay,
Yeah.
What about the face? Was that different?
Yes. Step 2 was the bas-relief for the face. Garlaschelli reported that while rubbing on a human body worked for the torso and limbs, the face must be obtained from a bas-relief to avoid the inescapable wraparound distortion.
Ah, the distortion problem.
Exactly. Trying to rub a flat cloth over a nose, cheekbones, it stretches and distorts badly. So they made a shallow plaster of Paris bas-relief for the face and used the same acidic pigment and frottage method there. showing different techniques were needed for different parts.
Makes sense. What about the scourge marks? Those look very different from the body image.
Right. Step 3, scourge marks. This is interesting. Garlaschelli noted the scourge marks and blood stains on the real shroud aren't fuzzy like the body image. They're sharp. So for their reproduction, they didn't add these by rubbing. Instead, the pigment this time, a mix mimicking blood color, red ochre, cinnabar, alizarin, in water, was gently applied with a small brush.
Painted on, basically.
Gently painted or dabbed on, yes. He said this brush application also created the fine, parallel scratches seen in some of the marks, highlighting again multiple techniques needed even within one artistic hypothesis.
Okay, body rubbed, face rubbed from relief, scourge marks painted. What next?
Step 4 was artificial aging. After applying the raw image and scourge marks, they aged the cloth artificially, heated it in a special oven, washed it thoroughly, ironed it flat. Garlaschelli proposed this heating simulated centuries of natural aging on the painted shroud.
Why was aging important to their theory?
His theory was crucial here. The shroud image we see today is not what the medieval artists originally created. He argued the original pigment eroded away over time. What we see now is a faint pseudo-negative image left, where the acid in the original pigment slurry chemically reacted with just the superficial layer of the linen. The aging supposedly revealed this underlying acid burn, explaining the superficiality and 3D properties as a result of aging, not the initial creation.
That's a clever twist. So the image changed over time. And
Yeah. Finally, step 5, blood stains and burn scars. The major blood stains were painted on, likely with similar red pigments and a brush, to mimic real blood. And to replicate the famous burn scars and water stains from the 1532 Chambéry fire, they used a pen-sized butane blowtorch and strategically applied water, covering all the bases.
That is an incredibly elaborate, well-thought-out process, really trying to account for everything: body image, face, scourge marks, aging, blood, even the fire damage. Sounds like they left no stone unturned trying to make a complete artistic replica.
It was indeed a significant attempt. It showcased the multifaceted nature of the shroud's image and demonstrated that a highly skilled, resourceful artist, using a combination of techniques, could produce something visually impressive and superficially similar in many ways.
But the ultimate question remains.
The ultimate question is whether it truly replicated all the unique characteristics, especially the finer, microscopic details, the specific chemical properties STURP identified. Could this multi-step process truly account for everything, or did the artist essentially have to use a different trick for every single feature? That's the debate.
Moving on, the idea of light playing a role seems to pop up again, leading us to Nicholas P. Allen's proto-photograph hypothesis. What was his core idea, especially given the apparent failures of previous artistic explanations?
Allen, a South African researcher, proposed and tested his ingenious hypothesis in the mid-1990s. He was partly motivated by studying all those previous artistic mechanisms and feeling they failed to fully explain the image, particularly this distinct photographic negative properties.
The core mystery revealed by Pia.
Exactly. Allen recognized the shroud image had many characteristics of a photonegative. This led him to conclude the best explanation wasn't painting or rubbing, but actually an early, primitive photography-like method from the Middle Ages, something far more sophisticated than tempera paint.
He felt the evidence itself pointed that way, didn't he? There's a quote about that.
Yes, he did. In his published paper, Allen stated, and I quote, "If one considers the facts as they are presented by the shroud as Sach selbst," that's German for the thing itself, it would seem that the only possible and logical way that the image on the shroud could have been produced was by a photographically related technique. He believed the object's inherent properties screamed photo, not painting.
So how did Allen actually try to create a proto-photograph using potentially medieval technology? What was his method?
Allen used a camera obscura technique, basically a dark box or room with a lens. He used a life-size sculpture of a human body as his subject, lit intensely by direct sunlight. The image of this lit sculpture was focused through a lens specifically, a quartz lens, about 6 inches or 15 centimeters across into a dark chamber.
And inside the chamber?
Inside was a chemically treated linen cloth, made photographically sensitive. He followed several steps, like early photo processes. First, treat linen with silver nitrate to make it light sensitive, like primitive film. Second, capture the frontal image of the sculpture. Third, change the setup, capture the dorsal image. Fourth, maybe change again for a separate detailed facial image capture. Finally, wash the cloth to remove leftover silver nitrate, fixing the faint image.
He got a compelling image this way, but what was the major flaw Barry Schwartz, the star photographer, pointed out, didn't he?
Allen did produce a visually compelling image. It showed a photographic method could create something with many of the shroud's macroscopic features. But questions were raised. The hypothesis struggled to gain traction, mainly because of one huge problem pointed out by Barry Schwartz: historical incongruity. Meaning, the historical context is fundamentally flawed. Schwartz makes the point that no medieval examples of Allen's precise technique requiring a specific quartz lenses, chemicals like silver nitrate used this way, have ever been found anywhere. Allen couldn't produce even one historical example from the period 1260–1355, the typical medieval dating window based on the C14 results.
So if the shroud is a photo, it's the only one known from that era.
Exactly. It would be a complete technological unicorn. And furthermore, if the shroud existed before 1200, as considerable historical evidence suggests, then the probability of Allen's method being used becomes, as Schwartz put it, vanishingly small. The tech simply wouldn't have existed then.
Beyond the history, were there other issues?
Yes. Besides the historical problem, there were also inconsistencies with the full context of the shroud's image characteristics. The micro details of blood, the absolute superficiality that Allen's method couldn't fully explain. It shows how even an ingenious experiment can fail due to broader historical context, or by not ticking all the boxes of the evidence.
A powerful critique indeed. Now, speaking of light and sun, Nathan D. Wilson's shadow shroud hypothesis also uses sunlight, but very differently. How does his method work?
Yes, Allen's work reinforced the idea of light's role. Nathan Wilson's shadow shroud hypothesis builds on this, using sunlight, but as Wilson noted, his method is quite different in its details from Allen's.
How does it work? It sounds intriguing, almost like a reverse process.
It is simple and ingenious, working on a subtractive principle. Wilson starts with linen that's already uniformly aged or colored to match the maximum intensity of the shroud image. How exactly he aged it isn't specified, but you start with a fully colored cloth.
Okay, start with brown linen, then what?
Then the core is using a painted piece of glass. The artist paints a positive image onto the glass, like a transparency. This painted glass casts a shadow onto the aged cloth placed underneath. The denser the paint, the darker the shadow.
And the shadow protects the cloth.
Exactly. The shadow protects the cloth beneath the painted image from sunlight. Then the sun bleaches and fades the unprotected parts of the cloth. The area is not covered by the shadow.
So it's like revealing the image by bleaching away the background, like a sculptor carving away stone.
Precisely. The shadow doesn't create the image directly. It protects the image already present in the colored cloth, while the sun removes everything else. Like a sculptor reveals the statue hidden in the rock by removing the unwanted stone. Wilson uses sunlight as the tool to remove the unwanted color, revealing the image. A very clever inversion.
What kind of results did he get?
The method can produce an image, and its quality depends on the artist painting the glass shadow. Wilson produced a compelling negative face by photographing his positive shadow shroud result. It showed pseudo-3D properties, intensity related to shadow density, and photonegative attributes.
But again, limitations compared to the real shroud.
Yes. Wilson, like others, only experimented with a facial image, no blood details. That's a significant omission. More critically, despite the interesting visuals, there remain, quote, insurmountable inconsistencies with the actual shroud images of a dead and tortured human body. The overall complexity, the specific characteristics, the crucified body details, the distinct blood patterns, the fact the images formed on the cloth, not just revealed by removing color, aren't fully accounted for. Compelling artistically for some aspects, but not the whole story.
Fascinating how many artistic routes have been tried. Each explains some things, but stumbles on others. Okay, let's shift now to our third major category. Hypotheses involving radiation or electric fields. Energetic phenomena. First up, the radiation fall-through hypothesis from John Jackson. This is a big one, isn't it?
Yes, this is one of the most developed and influential hypotheses out there. John Jackson and his TSC research team developed this radiation-based idea. It's theoretically consistent, they argue, with all the known shroud image characteristics. It's called the radiation fall-through hypothesis, first proposed around 1989, and continuously refined since, mainly through theoretical modeling and computer simulations.
What sparked this line of thinking for Jackson? Why move towards radiation?
The unique, unusual, three-dimensional characteristic of the shroud image was the primary inspiration. In their original analysis, Jackson and colleagues found this close correlation between image intensity and the vertical distance to a hypothetical body inside the cloth.
Closer body part, darker image. Essentially, yes. And experiments with volunteers confirmed this distance correlation was vertical, seemingly linked to Earth gravity. The image intensity mapped how far a body part was from the cloth surface along a straight vertical line. This crucial observation led Jackson to think gravity was a decisive factor, pointing towards a non-contact, energetic event, not simple chemistry or art.
Did they do any lab experiments to support the image formation part, even if they couldn't recreate the whole event?
They did. Jackson's team experimented by irradiating linen samples with ultraviolet light. Then they heated the cloth in an oven for artificial aging, which darkens linen over time. They found the irradiated and aged samples developed a superficial colored layer that visually and chemically closely matched the shroud's image fibers.
So UV light plus aging could create the right kind of color change.
It provided a physical basis, yes.
Yeah.
Suggesting some form of energetic radiation could indeed create the very specific type of superficial image chromophores seen on the shroud.
Okay, putting it all together, how does the radiation fall-through hypothesis actually work? It sounds profound.
Sure.
It is profoundly unique. In brief, the detailed hypothesis states that, at the moment of image formation, the body wrapped in the shroud became volumetrically radiant.
Volumetrically radiant,
Imagine the body itself, throughout its entire volume, not just the surface, suddenly becoming a source of light. Specifically, light in the vacuum ultraviolet range, VUV, emitted from every point inside the body.
Okay.
Simultaneously, the hypothesis proposes the body became mechanically transparent. Think of it becoming insubstantial, ghost-like, offering decreasing resistance to the cloth as the cloth simply collapsed or fell through the space the body occupied, pulled down by gravity.
Collapsed through the body space.
Exactly. Then, the irradiated cloth, over time, maybe centuries aged, and the faint, superficial image developed into its physical form. It posits a singular, highly energetic, instantaneous event involving a complete transformation of the body.
That sounds like something you can't exactly repeat in the lab. How does science even evaluate a hypothesis like that?
You're absolutely right. It posits a singular event, modeled theoretically and via computer, but clearly not physically replicable today. However, and this is crucial for science, the hypothesis does make specific, testable predictions about image characteristics that can be evaluated using existing data from the shroud.
So you test the consequences, not the event itself.
Precisely. It's a hallmark of good science. Even if you can't recreate the event, you look for evidence of its predicted effects on the artifact. It shifts inquiry from replication to verification of predicted properties.
And what was one of its most powerful, most surprising predictions?
This is a truly remarkable point, one of the strongest arguments for the hypothesis. While developing the fall-through idea, Jackson predicted there should be traces of a doubly superficial image associated only with the frontal image.
Doubly superficial, like on the back side of the front image.
Exactly. The reasoning was, as the cloth hypothetically collapsed through the radiant body, the VUV light would also irradiate the back of the cloth facing the body, leaving a faint impression there too. What's extraordinary is he made this prediction while the Holland backing cloth still covered the back of the shroud in Turin.
So predicting something hidden for centuries.
Yes. At the time of Jackson's prediction, the back of the shroud hadn't been seen for hundreds of years. No one knew what, if anything, was back there.
Incredible. Was it ever confirmed?
Yes. Years later, in 2002, when the Holland backing cloth was finally removed for conservation and the back of the shroud was meticulously studied, a faint superficial image of the face, and possibly the hands, was indeed observed on the back of the cloth.
Wow. It matched his prediction.
Perfectly confirmed Jackson's prediction,
Yeah.
demonstrating the powerful analytical and predictive strength of the fall-through hypothesis. It's incredibly compelling evidence. Independent verification of a previously unseen predicted phenomenon is rare and powerful in science. It shows the hypothesis could anticipate new discoveries, not just explain old data.
That is truly astounding. Now, Mark Antonacci has offered an intriguing variation on Jackson's idea, suggesting a different type of radiation. What's his take?
Right. Shroud scholar Mark Antonacci, in his 2015 book, Test the Shroud, endorsed Jackson's overall fall-through mechanism, but proposed a fascinating twist on the energy source. Instead of VUV light, Antonacci and his collaborating scientists proposed particle radiation, specifically protons and neutrons, as the source of the image and other shroud phenomena.
Protons and neutrons, not light. Is there a connection here to the controversial C14 dating results?
Absolutely. And this is where it gets particularly interesting and provides a strong motivation for Antonacci's idea. Thomas J. Phillips from Harvard's High Energy Physics Lab was actually the first to suggest a neutron flux. A burst of neutrons might be linked to image formation.
When did he suggest this?
Right around the time the 1988 carbon dating results were announced. Because it's known that a neutron flux can skew the carbon-14, carbon-12 ratio in linen. It adds neutrons, create more C14, making an old cloth appear artificially younger when dated.
Ah, so a potential explanation for the medieval date.
A potential explanation, yes, offering a mechanism for why an older cloth might yield a younger date.
So Antonacci's team built on this neutron idea, linking image formation to the dating anomaly. How does their full hypothesis work?
Exactly. Following Philip's lead, Antonacci's team constructed a complete, testable hypothesis. They proposed that if particle radiation protons and neutrons formed the image, then not only would a superficial body image be left, but unstable isotopes should also have been formed in the linen fibers during this energetic event.
Unstable isotopes, like radioactive elements.
Yes, and crucially, they argued several of these isotopes would have half-lives long enough to still be present today, but short enough that they aren't found naturally, making them unique fingerprints of this specific event.
And this leads to specific, testable predictions, a way to prove or disprove it.
Yes. Specifically, they proposed that if this historically consistent hypothesis, as they call it, is correct, then rare radioisotopes of chlorine, Cl, and calcium, Ca, should be detectable on the shroud, byproducts of neutron bombardment.
Which is why he titled his book, Test the Shroud.
Precisely. Test the shroud at the atomic and molecular levels, emphasizing the need for direct atomic level testing on the relic itself. Antonacci summarizes it powerfully in his book. Let me quote a part.
Please do.
Only hypotheses involving a burial cloth collapsing into a radiant region once occupied by a disappearing or mechanically transparent body can account for all the shroud's primary and secondary body image features. However, only the historically consistent hypothesis involving particle radiation can also account for the shroud's still red color of its blood marks, its possible coin and flower images, its excellent condition, and its aberrant medieval radiocarbon dating.
That's a huge claim, trying to explain almost everything anomalous about the shroud with one mechanism.
A truly comprehensive claim, yes.
What are the prospects for Antonacci's version? How could it move forward?
Well, Jackson's VUV light version is arguably more mature, theoretically. It's gathered more support over the years, including from Antonacci's own team members. But the next crucial step for Antonacci's particle radiation version is preparing a detailed testing proposal, outlining exactly how to detect these rare isotopes.
And submitting it to Turin?
Submitting it to the Shroud custodians for approval. If approved, the test could be carried out. Confirmation of those specific Cl and Ca isotopes, that would undoubtedly be a landmark discovery, potentially revolutionizing our understanding of the shroud's origin, maybe even its age.
Let's shift slightly within this energetic category to electric fields. Giulio Fanti, another prominent name, proposed the corona discharge CD hypothesis. How might that have formed the image?
Giulio Fanti, a professor at the University of Padua, built on earlier experimental work by Oswald Scheuermann from the 80s. Fanti proposes a corona discharge phenomenon was responsible for the image, arguing it could create many observed characteristics.
Okay, remind us. Corona discharge, what is that in simple terms? Not the beer.
Not the beer, no. A corona discharge, or CD, is an electric discharge. It appears on and around the surface of a charged conductor, in this context, the shroud body shape acting as the charged object. It's caused by the ionization of the surrounding air due to a strong electric field. Think of that faint, glowing, often bluish discharge around high-voltage power lines, especially when it's humid, air breaking down electrically.
Okay. And what conditions might create or intensify this, especially in, say, an ancient tomb?
Fanti explains the threshold voltage needed for a CD can be significantly lowered by radon gas. Radon is radioactive. It ionizes the air naturally. It's often found in confined spaces, especially near Jerusalem with its geology tombs, basements.
Radon gas and earthquakes.
Yes, that's key to Fanti's idea. Radon levels can be significantly increased by earthquakes releasing trapped gas. And the Gospel of Matthew mentions a strong earthquake around the time Jesus was entombed. Plus, CD phenomena have been observed and documented scientifically during earthquakes and with high radon levels. So there's some environmental plausibility.
And what would the corona discharge actually produce that could make an image on linen?
A CD emits light, mainly UV, from energized air molecules. It also produces chemical byproducts, ozone, nitric acid, other reactive species like nitrogen oxides. Fanti suggests these UV light emissions and reactive chemicals might have caused the superficial chemical changes on the linen, creating the image.
Did Fanti's team test this experimentally?
Yes, extensively. Their experiments are among the most thorough in this area. They use a half-scale metallized mannequin covered with cloth, placed it in a high-energy electric field producing a CD.
And the results?
They did produce a superficial body image. It had some 3D characteristics, intensity related to distance, and even double superficiality effects, like the faint image on the back. However, the image itself was described as very distorted, not matching the shroud's anatomical precision. It points again to the huge difficulty of controlling a high-energy discharge to produce such a detailed, undistorted image.
There was some related research too, wasn't there? Maybe connecting to Jackson's VUV idea.
Indeed. In 2012, scientists at the ENIA Research Center in Frascati, Italy, published a paper in Applied Optics titled Superficial and Shroud-like Coloration of Linen by Short Laser Pulses in the Vacuum Ultraviolet.
Laser pulses.
Yes. They successfully produced superficial, shroud-like coloration on linen using extremely short, high-energy pulses of VUV laser light. These findings might be relevant to both Jackson's VUV hypothesis and Fanti's CD hypothesis, as both phenomena can produce VUV light. It suggests high-energy, pulsed VUV light, whatever its source, could be a viable mechanism for the specific image coloration.
Fascinating link. Okay, finally, in the electric field category, the electric charge separation hypothesis from Spicer and Toten. What's their concept, and why is it very interesting, even if untested?
Like Fanti's, this hypothesis relies on an electric field in a confined tomb during an earthquake. But Spicer and Toten introduce a unique twist. They suggest sweat on the body might have been the primary vehicle for image formation, not direct discharge from the body.
Sweat. How would sweat work in an electric field model?
Sweat contains urea. Urea is acidic. It can yellow cellulose, linen, over time. Their key idea is that the urea molecule has a large polar moment, meaning it has slightly positive and negative ends, like a tiny magnet. They propose this polarity might cause urea molecule to attach, preferentially, be concentrated by molecular charges on the outer surface of the shroud cloth, which is a poor electrical conductor, a dielectric.
So the electric field acts like a filter concentrating the urea.
Sort of. They emphasize a low-energy electric field, not a dramatic flash. Reactive polar molecules, like urea, diffuse from the body. The field concentrates them at specific locations on the cloth, mapping the body's geometry onto the surface without direct contact, creating the image via chemical reaction from the concentrated urea.
Why is it interesting but untested?
What makes it interesting is its elegance. It leverages common biology, sweat, urea, and basic physics, polarity, electric fields, in a novel way to explain image formation and superficiality. It sounds quite plausible theoretically.
Ain't no experiments yet.
While it's a very interesting concept, theoretically compelling, it hasn't been experimentally tested to the degree Fanti's or Jackson's ideas have. This limits detailed evaluation against all the shroud characteristics. It highlights the ongoing nature of science. Brilliant ideas sometimes await rigorous experimental testing. A clear path for future research, though.
Well, we have just journeyed through an incredible range of scientific and artistic ingenuity, from ideas about natural body processes to elaborate artistic techniques and even, well, theoretical physics, energetic phenomena like radiation and electric fields. It's really a testament to the shroud's enduring mystery that so many brilliant minds have tackled it from so many different angles.
It truly is. And each hypothesis we've discussed, regardless of its ultimate fate, whether it was disproven, is still being refined or is waiting for tests. It contributes significantly to our understanding the shroud's unique characteristics and the profound challenges in replicating them.
We really saw the importance of hard evidence, didn't we?
Absolutely. Empirical evidence, reproducibility, and, most crucially, consistency with all known image features. A hypothesis might explain one or two things beautifully, but to really stand up, it needs to explain everything, from the big picture down to the microscopic chemistry.
And despite, over a century now of intense study and breakthroughs like STURP peeling back so many layers, the core question of how the shroud's image formed remains this profound scientific puzzle. One of the great unsolved mysteries, really.
Absolutely. And, this isn't a failure of science. It's actually a testament to the shroud's truly exceptional properties. It keeps challenging our assumptions. It pushes the boundaries of our knowledge, forces us to think outside conventional boxes. The shroud acts as this sort of scientific crucible where hypotheses are constantly forged, tested, driving deeper inquiry into physics, chemistry, history.
Which leaves us with a provocative thought for you, our listener, to mull over. As we've seen, some hypotheses, like Jackson's fall-through, they gain immense strength from their predictive power, right? Even if the event itself seems unrepeatable. Others, they get shot down by a single critical piece of empirical evidence, like the image's superficiality ruling out simple contact or deep penetrating vapors. So what does it truly mean for a scientific theory to be true when it involves a singular, potentially unrepeatable event? And thinking about the shroud itself, what new insights might it yet reveal? Not just about its own origin, but maybe about the very limits of our scientific understanding of the natural world.